Hey, my name's Jared. Today we're going to be talking about the sympathetic nervous system, the parasympathetic nervous system, as well as the somatic nervous system a little bit, comparing and contrasting them, as well as what kind of actions they have, exceptions to rules, and what kind of neurotransmitters they use. So first things first, let's start with where everything originates from the central nervous system. So in your spinal cord, you have different horns that come out. Somatic's probably the simplest, with your dorsal and ventral horns that have sensory neurons as well as motor neurons. That's how you can touch things and feel them, as well as move your muscles. That's what will innervate that. These only have one nerve, because you only need one nerve to feel something, and you only need one nerve to move a muscle. Jumping over to sympathetic and parasympathetic, where they originate, they're going to originate in the lateral horn of your spinal cord. So the cell body is going to be in this lateral horn area, and sympathetic has 4 different routes it can go through. We'll start with this one. Depending on where you want to go, you can synapse in the sympathetic chain ganglia, which is located right next to the spinal cord. And after you synapse in there with another cell body, you can either form a spinal nerve and innervate body cavity tissue, or you can also form a sympathetic nerve, also forming innervating tissue within the body cavity as well. Basically all of these innervate all these body cavity tissues. Another one will travel straight through the sympathetic chain ganglia. They won't synapse there with the cell body there, but they will form a splanchnic nerve, which will synapse at a collateral ganglia, which is located in visceral tissue, and it will basically spread the signal out into multiple different nerves. And then finally, we have one that will travel straight through collateral ganglia to the adrenal medulla, where they'll stimulate the adrenal medulla, which will release epinephrine into the bloodstream and cause other things within the body. So just to be clear here, when we talk about the sympathetic system, I don't think I got parasympathetic. On the other hand, parasympathetic originates in the lateral horn, actually like the cranial and sacral division, whereas sympathetic is in your thoracic region. Back to parasympathetic, you have 2 nerves here as well, and these usually travel all the way to the organ they innervate, and they have a very long first neuron and then a very short second neuron. And they call those terminal ganglia because they're so short, or they're so close to the effector you're innervating. So back to this, sympathetic will mean you're fighting or you're flying, right? Your body wants to move. If you're in front of a bear, your body's like, okay, let's do everything we can to get moving, pump more blood, etc. Parasympathetic is associated with rest and digest. So after that big experience with the bear, you want to calm down. It's going to innervate things and cause them to calm down or relax. So let's jump over here and kind of discuss what kind of neurons we're dealing with and what neurotransmitters we come up with. So in the sympathetic nervous system, our fight or flight nervous system, essentially, we have a cholinergic neuron, which will release acetylcholine, which is our neurotransmitter. This will then hit a nicotinic receptor on your second cell body, and then you'll have an adrenergic neuron, and that adrenergic neuron will release norepinephrine, which is another neurotransmitter, which will be received by receptors alpha and beta, and we'll dive into that later. Parasympathetic, on the other hand, is also cholinergic, and it will be cholinergic through both neurons all the way to the receptor. Cholinergic will produce neurotransmitters acetylcholine on both ends of the neuron, and it will stimulate or be received by muscarinic M1 through 5 or 1 through 5 receptors. Somatic nerves just travel straight through. They're cholinergic. They release a neurotransmitter acetylcholine, and that will stimulate N1 receptors, which usually innervate skeletal muscle. These are all effectors over here. The neurotransmitters will hit those effectors, and we're doing what we need to do, either exciting something or inhibiting something. That said, each of these receptors have a number associated with them. For alpha, you have 1 and 2. For beta, you have 1, 2, and 3. Nicotinic 1, nicotinic 2, muscarinic 1 through 3. There's 5, but we're just focusing on 1 through 3 today. Even numbers typically inhibit action. Odd numbers typically excite when they receive a neurotransmitter telling it what to do. So that said, adrenergic receptors, ones that receive norepinephrine, are all alpha and beta receptors. Alpha 1, because it is odd, will excite things, so in your blood vessels it'll cause it to constrict. It will cause your pupillae or your pupils to dilate. Alpha 2, it's an even, so it will inhibit your insulin secretion. If you're inhibiting something like insulin secretion, you're not producing as much. In that fight or flight area, all of these are basically the fight or flight response associated with sympathetic. And so sometimes with adrenergic receptors, you need to excite something or you need to inhibit something with the fight or flight response. So it can kind of have a double action there. Beta 1 receptors, it's an odd, so it will excite cardiac myocytes, causing your heart to pump a little faster. Beta 2, that is even, it will inhibit the smooth muscle of your airways, so you don't need to constrict your lungs as much. You open up your lungs so you can get more air. In that fight or flight response, you need more air. And B3, lipolysis, that's an odd, so it's going to be excited. In a fight or flight response, you need energy. You're going to break down fats for that energy quickly. These are all G protein coupled, which cause cascading effects. And so let's move on to cholinergic receptors. We have nicotinic 1, nicotinic 2. These are ionotropic. They're not going to have that G protein coupling. They're just going to receive a neurotransmitter and send it on its way through another neuron. And N1, usually you'll find that on skeletal muscle and somatic nerves. It's cholinergic. It's going to help you lift weights, move your muscles faster. N2, nicotinic 2 is even. N2 you'll find on neurons, that's gonna just cause the neuron to synapse and send on its message. And then moving on, you have all of your muscarinic receptors. These are all pretty much associated with a sympathetic, or with parasympathetic, with rest and digest. So you're going to calm things down anytime you're in a relaxed state. These are what those receptors will do. For example, M3, it's odd. So it's going to excite your sphincter pupillae. So by exciting your sphincter pupillae, your eyes are going to constrict and get narrower. You don't need to have as much light entering your eyes when you're relaxing. Some exceptions to this rule of sympathetic with cholinergic and adrenergic neurons is in the cases of sweating. And with sweating, you're going to have two cholinergic neurons, each producing acetylcholine as the neurotransmitter, and you're going to be sending that to a muscarinic receptor. And what that's going to do is cause you to sweat and regulate your body temperature a little bit. So that's one exception where in a sympathetic nerve or nervous system, we're not producing norepinephrine at the end to our effector. Instead, we're producing acetylcholine to our effector so that we can sweat and regulate our body temp. Another one of these was sweating. This one follows this path, but it still has to do with sweating. Sympathetic nervous system follows basically the same path as this one previously mentioned. You have acetylcholine from the first neuron, it's cholinergic, and then from your second neuron, it'll be adrenergic, producing norepinephrine, and that will be local sweating, which is usually caused by stress. So in the armpits, clammy hands, or sweaty palms, and that will be an alpha-1 receptor, which will cause you to sweat in localized regions like the armpits or the palms of your hand. So that's essentially the parasympathetic nervous system, the sympathetic nervous system, and the somatic nervous system, where they originate, how many nerves are in their systems, and which kind of actions they do, as well as what kind of receptors respond to different neurotransmitters. And that's it for the nervous system.